Okay, thanks everyone. So we've had an excellent talk this morning already from Carl Braganza from the Bureau of Meteorology head office in Melbourne, giving us an excellent overview of a variety of changes, including fire season, touching on changes in fire seasons. I'm basically based locally here in the South Australian office, so looking after climate-related matters in South Australia. We're seeing, right at the moment, we're just seeing some interesting in terms of significant climate, in that we're having record heat for this time of year. So we had 36.3, I think it was, yesterday in Adelaide, which is the equal second hottest day we've had this late in autumn, and record runs of hot days across Australia. We've also got some fire activity going in various locations around the state at the moment as well. So my talk is going to look a little more closely about trends and changes in fire weather and variability in fire weather and fire seasons in South Australia. There's a lot of people in the room would be familiar with how fire weather is measured, but for those who haven't been exposed to that, there's two different ways used in South Australia. There's calculations of grass fire danger index, and I promise these are the only equations you're going to see in the presentation. So grass fire danger index, uses air temperature, wind speed, relative humidity, and then also some fuel moisture and fuel amount variables, so degree of curing, fuel load. Now the data sets of those aren't particularly long, and they're a bit subjective, and there's some issues around how far you can go back and calculate grass fire danger index, despite the fact that it's actually a more representative calculation or indicator across much more of South Australia than the forest fire danger index. Now the FFDI once again uses air temperature, wind speed, relative humidity, but it uses something called drought factor in there as well. Now, drought factor is calculated from something called soil dryness index, and that's determined from daily values of maximum air temperature and daily rainfall in a sort of on cumulative calculation. Now, that means that drought factor is a lot easier to calculate back in the past. So we have got actually relatively good records going back of soil dryness index and hence drought factor. But the limit is still, one of the limiting factors still there in terms of looking back into the past of past fire behaviour is really wind speed. So because wind speed is such a key component in the calculation of fire danger indexes, it is a major limiting factor. So we're really limited to wind speed records from automatic weather stations that typically only go back to about perhaps the early or mid 90s, 1990s, and so what have we got? We've got automatic weather station data we can chuck into an calculation of FFDI. This gets done on a daily basis within the Bureau through the fire season in our forecasting centre back in the Adelaide office. So both the GFDI, FFDI calculated, and we run our forecast data through that. That then spits out a value of FFDI, GFDI, and then that gets assigned various fire danger ratings then pop out of that. So, is today going to be severe? Is it going to be extreme? Is it going to be catastrophic? Come out of those calculations of GFDI and FFDI. Now, in terms of looking back in the past, there's a whole lot of traps. So things like changing the type of wind head that's used for measurement of wind. So we used a different type of wind head back in the 80s and 90s, and we changed that through the 1990s. So that's a potential step change. Changes in the way humidity is measured. So there's a whole lot of potential traps in terms of trying to look at trends in things like FFDI. And that, once again, that limitation, we typically only have measurements from a number of locations from the mid to late 1990s. So just note there those categories: severe, FFDI is 50 to 74, extreme 75 to 99, and the catastrophic for FFDIs is 100 FFDI plus. I'm just going to do a little quick sidestep into climate influences. This is relevant to the variability that we'll see through the fire seasons. So a lot of people would be familiar with the hot and dry conditions that come from El Nino events. So the map on the top left there is typical rainfall through El Nino events that impact Australia from the Pacific Ocean, and leading to dry conditions and hot conditions through winter and spring. Another La Nina events are the opposite phase. So we tend to be warmer waters around northern Australia, leading to increased rainfall and wetter winter and spring conditions on the blue areas on the top right. The Indian Ocean is also a very significant influence across South Australia. We have the Indian Ocean dipole, which is a pattern of variability in the northern Indian Ocean. The positive phase, which means cooler water near northwestern Australia, we get reduced cloud, reduced rainfall, and hotter and drier conditions through winter and spring, more focused on South Australia. And the negative phase, which we saw in 2016 quite strongly, we see warmer water to the northwest of Australia and more moisture, more cloud, and milder and wetter winter and spring conditions. So what I've done here, I've just graphed up, calculated past FFDIs for Mount Crawford using all the available high-frequency data. So that goes back to the mid-1990s. The blue bar in the bottom is the daily rainfall amounts. And I've got the severe category, so the 50 to 74 FFDI, extreme, and then the catastrophic 100 plus on there in the red dots, just through each year, and then just showing the distribution through the year for each season. So a few things that pop out of that. If you plot La Nina negative IOD years, so those are those years there, you can see the much reduced amount of severe, extreme, and catastrophic days overall. So you get less severe, extreme, catastrophic fire days. And the other thing to note there is the seasons typically start later. So for Mount Crawford, it's starting more through December, January rather than through spring. El Nino, positive Indian Ocean dipole years, we tend to see a much earlier start, so typically starting more through spring, October, November, higher numbers of extreme days. What is interesting is that the seasons don't necessarily stretch on later. So you might expect that the fire season starts earlier in El Ninos, that it might actually end later. Now that's interesting that that's not necessarily the case. So that's something that's, I think, worth looking into a little bit more closely. So there's some further work in there with that, but it's quite an interesting feature that the latest finishing fire seasons aren't the El Nino negative Indian Ocean dipole years. So looking at, and I guess the other interesting feature is there's a bit of a trend there in terms of the earlier starts overall. Now we don't have a long enough record to get a really good, robust quantification of that sort of trend, but typically across southern and eastern South Australia, we're seeing about a month or so earlier start to the fire season on average. At the other end of the season, some areas a slight later trend, but it's not really significant. There's a great deal of variability in the end of the fire season. We're seeing a similar sort of thing in the southeast. So we look at, once again, La Nina negative Indian Ocean dipoles, El Ninos and positive Indian Ocean dipoles, similar sort of pattern, much less activity in La Nina years, and once again, similar sorts of trends in terms of the start and finish of the fire season. So on to looking a little bit further afield, so on to Woomera, obviously a lot more potential fire activity in that sort of hotter and drier part of the world, and not different sort of stories. We're not seeing really significant trends in terms of start or finish of the fire season. Once we move away from the and east of the state. And similar sort of story for Ceduna. If anything, there's actually a later start to fire seasons over on the west coast there. Now, one of the questions, so Carl showed I think what's going on with these trends is Carl showed the drying trend across southeastern Australia, and also talked about the warming trends. So this earlier start to the fire season looks to be a compound effect coming from the changes in drought factor. So drought factor is calculated from maximum temperature and rainfall. So in areas where you're seeing a rainfall decline and warming temperatures, we're seeing drought factors, the time at which drought factors reach the highest level, so fuel's completely dried out, is a similar trend to what we're seeing there. Is happening about a month or so earlier in the southeastern parts, southern and southeastern parts of the country, and seems to be the major driver behind that earlier starts to the fire season. Now, something else I was interested in the question. So we're seeing strong warming trends. Temperatures over the last 20 years or so have warmed up about 0.6 of a degree across South Australia. So if we look since about the mid-90s there on that graph. So what I did is took the forest fire danger, took the automatic weather station data, detrended the maximum temperatures, and then popped those back into the FFDI calculation to see what difference that half a degree of warming or so over the last 20 years has made. And it's made a little bit of difference, but it's not the major driver in terms of the trends that we're seeing in terms of. So I've got graphs there of Woomera, Renmark Aerodrome, numbers of FFDI greater than 50 days, and we can see significant increases over the last sort of 20 years. So 40 days there at Woomera, getting up to about 60 odd more in the last sort of 10 years or so. Similar sorts of increasing trends at Renmark, so up from 20 up to about 30 odd. So significant increases there. The dashed line is the numbers of days if you detrend using the detrended maximum temperatures. Renmark's interesting. So both locations we're seeing about 10% more days of FFDI greater than 50 from that background warming. Similar story for Narracourt, Mount Crawford, and onto catastrophic days. Slight increases at Woomera, but Renmark, it's interesting, there's quite a number of days in recent years that wouldn't have had any catastrophic days in the fire season without that background warming trend. So just to finish, so I've just touched on some of the challenges that we have with the lack of data. So that's all station data I've been showing from automatic weather stations. One of the things the Bureau has been doing the last couple of years is doing some high resolution reanalysis projects. So I've got a project up called Barra, and that's basically taking a current state-of-the-art weather model and rerunning that retrospectively using available observations back into the past, and it gives you a much better representation of what's happening with climate down to possibly about a 1 kilometre resolution. And so we've got it Australia-wide, and we've got some regional scale reanalysis data sets that we've been running, and that gives you the potential to look at trends in things like fire season, FDIs, evapotranspiration, other parameters, using things like wind, humidity, and that sort of thing at high resolution. So that's about it from me. So just to summarise, we do see significant variability. So La Nina and El Nino events are quite important in terms of the start of the fire season. We're seeing trends in drought factor, and the onset of fire seasons about a month earlier across southern and eastern parts of the country. Increasing background temperatures are having an influence, but I think it does look like drought factor and changes in drought factor are the major impact. And so one of the things I'm looking to do is actually go back and recalculate soil dryness index using detrended rainfall and temperature data, and just have a look at, explore the impact that has. And I guess I'll just finish with a point. So soil dryness index, FFDI, it all sounds a little sort of, is it just relevant for fire behaviour and fire seasons and the CFS? I actually think it's indicative of changes we're starting to see in water availability in our ecological systems, which there's some significant changes, and those compounding influences that Carl touched on really starting to show up, I think, in our in things like water availability in our ecological systems, and that's, I think, looking likely to have some significant impacts on things like tree die-off and other factors that it'd be great to talk to people in that area a bit more about. Thank you.